So this is a video for section 6.1. Remember, I also have Miss Evans' videos also on D2L, so you can watch her videos on the same material. I'm not going to actually go over any of these definitions. These notes are going to be posted on D2L as well, completed notes. These are just the language that I'm going to be using in this section. You've probably heard most of these before, so I'm not going to take time to go over them, but you can go back and read them. There are two things that my lab talks about. It talks about linear equations. So linear equations are just those that if you graph it, it would make a line. So that would be, it wouldn't have an x squared or anything in it. Equations that have an infinite number of solutions, in other words, lots and lots of numbers would make it true. My lab calls that an identity equation. You can remember it with the I's, identity and infinity. If it has no solution at all, it's called a contradiction in my lab. So we're just going to basically go over how to solve equations in this section. So one of the main traps that some people mess up with is they start dealing with exponents, start moving exponents around or changing exponents. If you have 3 pizzas and I give you 5 more pizzas, you have 8 pizzas. You don't have square pizzas. Okay, so 3p plus 5p is 8p. You do not have 8p squared. You only change the exponents when you multiply. So here's a note. In your notes it says a variable never changes. And that is true, but I'm specifically talking about exponents. Exponents never change when you're adding and subtracting, okay? You just add and subtract the coefficient. Remember, coefficient is just that number in front of your letter. So, they talk about like terms and unlike terms. Remember, like terms, they have the same letter and exponent. So those are the only ones we can combine. So if I had 3 plus 6x for this first example, I would be finished. I couldn't do anything to that. I'm actually not going to work all the examples, but they are all worked and uploaded into D2L so you can go back and look at them. I'm just working some out of each section to make sure you understand how this works. So anyway, so let's look at our like terms in number 3. Notice you have 1x here and minus 8x. So think of that as 1 minus 8. So that's going to give me minus 7x. So those are like terms. And then your plus 3 and your plus 12 are like terms. So I'll have, what's that, plus 15? So that's my final answer. And you could write it as 15 minus 7x if you want to. Let's come back to the next one, number 4. Let's look at our x's. So I'm going to combine all my x's. So I just have 2 minus 3x plus 4x. That's going to give me, just 1x? And you can put the 1 there, but you don't have to. So I'm going to leave it off. I'm trying to get you used to how most math teachers will write it. Let's do y's next. So here's my y, minus 5 plus 2. So minus 5 plus 2, that's going to give me minus 3y. And then last but not least, we'll do just our regular old plain Jane numbers. Let's see, I'll do purple. So plus 2 plus 10. So that's going to give me plus 12. So my final answer would be x minus 3y plus 12. Now let's talk about the distributive property. The distributive property, I always think of it as distributing cookies. So I have 5 times the quantity 3 plus x. So I'm going to distribute the 5 to the 3 and get 5 times 3, which would give me, 15? And then 5 times a positive x. So that's going to wind up being 15 plus 5x. All right, so I'm going to work just number 2 and number 4. So number 2, I'm going to distribute my m times quantity n minus 3. So m times n would be just mn, and m times negative 3, that's going to give me minus 3m. Let's skip over to number 4. 1.3 times quantity x minus 2. So 1.3 times x is just 1.3x, and 1.3 times 2, 1.3 times 2 is going to give us what? 2.6. So that would give me a negative 2.6. So 1.3x minus 2.6. So that's the distributed property. Now we're going to distribute a bunch more and then combine like terms. So number 2, I have a 6 times quantity r minus 3. So I'm going to distribute that 6. So I get 6r minus 18. And then the next part of that equation, or not equation, but expression, is negative 2 times r plus 5. You might think of that as minus 2 times r plus 5. So you can think of that as plus a negative 2 if you want to. Either way, I'm distributing a negative 2 to those two in the middle. So that's going to give me minus 2r minus 10. And then the very last just said plus 10. So I can't do anything with that. So I will leave the plus 10. And then I'm going to go through and combine like terms, do what we did just a minute ago. So let's look at my r's. So I have 6r and minus 2r. So that'll give me 6 minus 2 would give me 4r. 4r. And then let's see, we actually have 3 regular numbers. So we have a minus 18, a minus 10, and a plus 10. Well, the minus 10 and plus 10, those can just cancel out, right? So all I really have is that minus 18. So my final answer would be 4r minus 18. Let's skip down and do this decimal. Now, when you have decimals, you can just use your calculator. So that's what I'm going to do. I'm going to say I have 0.9 times the quantity 2 plus 3x minus 2. So I'm going to distribute 0.9. So the first one is 0.9 times 2.3. 0.9 times 2.3. So that's 2.07. So I'll get 2.07x. And then I'm going to do the same thing. I'm going to distribute my 0.9 times my 2. So 0.9 times 2. Can come over here on my calculator again. 0.9 times 2 will give me 1.8. So when I distribute that, I'm going to get negative 1.8. And then the next portion said I'm going to have 1.7 times 3.2x minus 5. So I'm just going to distribute my 1.7 and multiply it by 3.2. 1.7 times 3.2 will give me 5.44. So I'll have a plus 5.44x. And then I distribute my 1.7 to my negative 5. Again, just plug 1.7 times 5 into my calculator, and I get 8.5. Now notice I didn't even worry about putting the negative because I know a positive times a negative gives me a negative. So that's 5.44x minus 8.5. And now I just need to simplify those and put them together. So I would do the same thing, just plug in my calculator, my x's. So for my x's, let's see what I get. I had 2.07 and I'm going to add 5.44. So I'll plug that in my calculator. I get 7.51. So I'll have 7.51x. And then negative 1.8 minus 8.5. Now notice that those two signs are the same, right? Both of them are negative. So when I put it in my calculator, I'm actually going to add those two together. So 1.8 plus 8.5 is going to give me 10.3. So I have 10.3, and notice both of them were negative. So when I subtract both of them, I'll get a negative 10.3. So mainly when you have decimals, you can just use your calculator. Now fractions. So I wanted to work both of these fraction problems because people get a little confused on fractions. So I have 2/3 times x plus 6. So the first thing I'm going to do is I'm going to write this out. 2/3 times x would be 2/3 x. And then plus 2/3 times 6. I'm going to literally write out 2/3 times 6. And I'll even do 6 over 1. I could go ahead and simplify that. Well, I'll go ahead and go to the next one. The next one is 1/6 times x plus 6. So I'm going to distribute my positive 1/6. So I get 1/6 x, 1/6 x, and then I'll do 1/6 times 6. So I get positive 1/6 times 6, and again you could do 6 over 1 if you want to, since we've got fractions. Notice that some of my fractions actually will cancel. Let's go back to the beginning, and I have my 2/3 x, and then I had 2/3 times 6 over 1. So notice the 3 on the bottom will divide into the 6 on the top. So 3 goes into 6 2 times. So I really am just saying 2 times 2. So that will give me 2/3 x plus 4. Then let's keep on going. I've got my 1/6 x. I can't do anything to 1/6 x. And then my 1/6 times my 6 over 1. Notice those guys are also going to cancel. So all I have left is plus 1. So my last step is that I need to combine my x's. So I had, I'm just looking, sorry. So I have 2/3 plus 1/6. Now you can, if you want to, do this by hand, but you also have a calculator. Now I don't have a calculator like yours, your scientific calculator. Your scientific calculator is much better than this fancy bulky one because it has an ABC button. So find the ABC button on your calculator, and this is how you're going to put it in. 2 ABC 3, so that gives you 2/3, and then you'll put plus 1 ABC 6 and hit enter, and it will give you 5/6 x. So we're combining the 2/3 x and the 1/6 x. So if you put that in your calculator, you're going to get 5/6. So that'll give you 5/6 x. And then let's combine the plus 4 and plus 1. So plus 4 plus 1, that's going to give me plus 5. So my final answer for that is 5/6 x plus 5. Let's go to the next one. I'm going to do the exact same thing. I have 2/3 times quantity 3x plus 9. So I'm going to multiply 2/3 times 3x, and again, I'm going to write 2/3 and then times 3x, and I'm just going to put it over 1, 3x over 1. Plus, I'm going to do the same thing, 2/3 times 9, and again, you could put 9 over 1 since we're talking about fractions. I think I'm going to go ahead and simplify that, if that's okay with you guys. I'm going to cancel out. I had 2/3 times 3x. Do you see how the 3 on the bottom and the 3 on the top cancel out? So I wind up with the first one is just 2x. So 2/3 times 3x just gives me 2x. And then 2/3 times 9, I can cancel again. I can put 3 into 9, goes 3 times. So 2/3 times 9 will wind up just being, what's that, 2 times 3? So that's just going to be 6. Because I just multiplied those tops together. So I've simplified the first one. Let's go to the next one, which was negative 1/4 times 2x plus 5. So I'm going to have negative, think of that as plus a negative 1/4 if you want to. Either way, I'm distributing a negative 1/4. So I'm going to add 1/4 times 2x, and I'll put that 2x over 1. and then I distribute the 1/4 and the 5. So that would give me, oh, I left my negative off, didn't I? Plus 1/4 times 2x, sorry. Plus negative 1/4 times 5. Now, none of those cancel, but a little bit cancels on my x. Notice that my negative 1/4 and my 2x, the 4 on the bottom and the 2 on the top, I can cancel that a little bit. 2 goes into 4 2 times. So I would wind up there with what, negative a half x. I can't do anything to that negative 1/4 times 5. So that's going to give me negative 5 over 4. So once again, I'm going to combine these guys together. I've got 2x and minus a half of x. So you can think of that. Think of pizzas. If I have 2 pizzas and I ate half, I'm going to have 1.5 pizzas left, right? I've got 2 pizzas. I ate half a pizza. So that's going to give me 1.5 x. Now, 1.5, I can't leave it 1.5. So I am going to say 2 times 1 plus my 1 on the top. That's going to give me 3/2 x. Now again, you could have taken out your calculator and written 2 plus or 2 minus, either way, 2 minus 1 ABC over 2. And it would give you 3/2 as your answer. So now let's do my regular numbers. Plus 6 minus 5/4. So you're going to do the same thing. You're going to put 6, you're going to put 6 and then plus and then a little negative sign, negative 5, hit your ABC button, 4, and hit enter. And your calculator will give you a positive 19/4. Now, some of your calculators, they probably will, some of your calculators may have given you, let's see, it shouldn't give you, it should give you a, yeah, they may have given you a, what would that be, a 4 3/4. They may have given you 4 3/4, which you could then write as a Dolly Parton fraction, a top-heavy fraction. So my final answer for that is 3/2 x, and it does matter where you put that x, okay? You can put it out to the side, or you could put it on top and write it as 3x over 2. So it can go out to the side, it can go on top, but it cannot go on bottom, right? So 3/2 x plus 19/4 is what you would put in your put in MyLab. All right. So now we are going to just evaluate some expressions. So we're going to substitute and simplify. Those are fancy words for plug and chug. I'm going to plug and chug. All right, so I'm going to plug a number in, and then I'm going to simplify it. So I'm not going to work all of these. I'm going to work the ones that are the hardest, okay? So number 3 has x squared minus 5x plus 12, and they want to know what that is when x is 3. So I'm going to take the 3, and wherever there's an x, I'm going to put the 3 in. So I'm going to have something squared minus 5 times something plus 12. And then I just put my 3 in. So that's going to give me 3 squared minus 5 times 3 plus 12. We're always going to do our squareds first. So 3 squared is going to give me 9. And then minus 5 times 3 gives me minus 15. And then I just have my plus 12. So I'm simplified now to 9 minus 15 plus 12. Now you could say 9 minus 15 is what? Negative 6 plus 12 gives me 6. You could do it that way, but I found the easiest way is to combine the ones that are positive. So 9 and 12 are positive, so that would give me what? 21. So I'm going to add those together, and then I subtract my 15. So that gives me a positive 6. Notice I would get the same answer no matter which way I did that. Okay, so that one is a typical one. But the next two, 4 and 5, have stars on them because they have traps. The main trap is, notice what you are plugging in with both of these. You are plugging in an x that is negative. whenever you're plugging in a negative, you have to watch out, okay? So I have something, I've got x squared plus 4x minus 7. So I'm going to do the same thing. I have something squared plus 4 times something minus 7. Then I'm going to go back and put my negative 5 in there. Negative 5 squared, 4 times negative 5 minus 7. Where most people mess up is this something squared. Negative 5 times negative 5 is going to be 2 negatives. That's going to give me a positive 25. So a lot of people miss that. Then you have plus 4 times negative 5, so that's going to give me negative 20. And then I have my minus 7 at the end. And again, I could do it in any way that you want. I tend to put those last two, since they're both negative, I put them together. So that would give me 25 minus 27. So 25 minus 27 is going to give me a negative 2 for my final answer. All right, I should double and triple star number 5, okay? Number 5 has all the traps. So notice when I write this down, I'm going to have a negative something, because it's negative x squared plus 3x minus 10. So I'm going to have negative something squared plus 3 times something minus 10. And then I'm going to go back in and plug in my negative 2, okay? And the very first term, this first one, negative of negative 2 squared, is where lots and lots of people mess up, because you have to do the exponent first, right? Please excuse my dear Aunt Sally. The parentheses, so anything that's in parentheses, if you can do it, do it. That we can't, there's nothing, that stuff that's in parentheses is just one number. So we're going to do my exponent. So negative 2 squared is going to give me a positive 4. But notice that I had a negative out front. I had a negative in front of my x squared. So I'm going to bring that negative down. So notice that anytime you square something, you always get a positive number. So if you have a negative in front of an x squared, that number is going to wind up being it's going to be negative. All right, then the next part is my plus 3 times negative 2. So that's going to give me negative 6. And then my minus 10 I still have. And notice all of those are negatives. A negative 4, a negative 6, a negative 10. So I'm just going to add them all together, and I wind up getting negative 20 for my final answer. Okay. So now we are just going to start solving some equations, okay? We'll talk about what is a solution. The solution is the answer that would make your equation a true statement, right? So, once again, I'm not going to work all of these. I am going to just plug in these numbers. They're asking, is x, the answer that they've given in number 2, the x is, that's supposed to say a regular 2. It had 2 equal marks. Sorry about that. Okay, so it says negative x squared plus 3x plus 6 equals 8. They want to know if it is a solution. So let's plug it in. All right, so I had a negative something squared plus 3 times something plus 6 equals 8. So I'm going to plug in just my 2 value. So I'll plug in a 2 in both places where the x was, and then I simplify. Now remember, we're going to do the squared first, so that's going to give me 2 squared is 4, and I bring my negative down. So that's going to give me a negative 4, and then 3 times 2 gives me a plus 6, and then plus another 6 equals 8. Let's see if this is true. Negative 4, I usually just add those 2 6s together since they're the same, positive 6 and positive 6. So I now have negative 4 plus 12 is 8. Negative 4 plus 12 is 8. So 8 equals 8. So yes, 2 is a solution. 2 is a solution. All right, let's do one more plug-in and then we'll start solving equations. So this one I have 3 times x squared minus 2x equals 40. So I'm going to write it out. 3 times something squared minus 2 times something is 40. And then I go ahead and plug in my -4. And once again, we have a major trap. You always do your exponent first. So I'm just going to leave that 3 out to the front. And then -4 squared gives me 16, right? -4 times -4. Let's keep going down the line. Now I have -2 times -4. That gives me a positive 8 equals 40. Now 13 times 16, that's 48. So, 3 times 16 is 48. So I've got 48 plus 8 is 40. Well, 48 plus 8, that's what, 56? 56 is not equal to 40. So -4 is not a solution. I mainly wanted to work that one so that you could see that main trap. Do your exponent first, okay? That is honestly the trap with most of these plug and chugs. All right. So here's some laws of equations. Basically, I was trying to prove something, but I'm not going to do that on in this video. But you may remember this from your Algebra 1 class, that whatever you do to one side of the equation, you must do to the other side of the equation. And that is what all that writing up there is for me to show you that if you don't, that it's wrong, right? It's not true. Okay, so I'm going to work just 2 problems. This one, notice it has x minus 8 equals 12. So we have to do the opposite. We got to move this -8 to the other side. So we're going to do the opposite. Instead of -8, we're going to say +8. Whatever we do to the left side, I've got to do to the right side. So on the left side, the -8 plus 8 cancel out, so you just have an x. So x equals 20 would be the answer. I'm going to skip the next one because it's essentially the same. This one I had a y plus 7 equals 9. So instead of adding on both sides, we're going to subtract my 7 on both sides. So I get y is equal to 2. Now, one thing I want to show you, I'm going to change it just a little bit, and I'm going to say y, I'm going to put it in a different color so you can see that I'm changing it. So that's going to be y plus 7 equals, let's say it is -9 instead of +9. This is where a lot of students mess up because we're saying that I am subtracting 7 on both sides, which I am subtracting it on the left, but notice that on the right-hand side, I have -7 -9 -7. So those signs are the same. So I would actually be adding those numbers together and keeping the sign. Do you see how it's a big difference? Right? So when I just change this one little thing, I make it a negative, it changes what you actually do to those numbers. All right. So that's just you need to remember, if you add or subtract on one side, you've got to do it to the other side. And the same thing is true with multiplication and division. Whatever you do to one side, you must do to the other side. Okay, so I'm doing the same thing. This was 7 times x equals 35. So to undo multiplying, we divide. So we would divide both sides by 7 because we're trying to get x by itself. So x would be equal to 5. I'm hoping this is coming back to your memory. I'm going to skip number 2. Look at number 3. So number 3 says x divided by 4 equals 8. So the opposite of division is multiplication. I'm going to multiply both sides by 4. Now I'm multiplying it by 4 on the left because I want those 4's to cancel out, and I just get an x. But whatever you do to the left, you got to do to the right. So you wind up having 8 times 4. So that's going to give you 32. So x is going to be 32. So sometimes you multiply and sometimes you divide. Usually you divide most of the time. Okay, So we have done some simple equations where you either added or subtracted or multiplied and divided and got the answer. So we are going to do much more complicated equations. So this is how you remember how to do this. Now, I love this when I'm teaching y'all in class because I don't give you any heads up and I just yell really loud, "Don't freaking call me after midnight!" And students that were asleep are now awake in my class and looking at me, and everyone else looks at me like I'm crazy. But that's okay. That's what I want you to remember. Don't freaking call me after midnight. I don't want you to call me after midnight. I won't answer. But that is the order that you do things. You're going to distribute, if you can, then get rid of your fractions if you have any. Then you're going to combine your like terms. Then you're going to move all the variables to one side. And in the same thing, you're going to be moving all the numbers to the other side. So the M stands for move stuff. Letters on one side, numbers on the other. And then you're going to add or subtract, whatever you need to do. And finally, you're going to multiply or divide, whatever you need to do. So I'm going to just work several problems. Again, I'm not going to work all of them, but the ones that I am not working, I already put the answers in this video so that you can go back and work them and then check your answers on D2L. Okay, so let's look at number 2. Number 1, the answer is going to be 11. But number 2, notice that the letter is on the right-hand side. Some students don't like that, but that's okay. You can flip it around if you want to. But we need to remember, don't freaking call me after midnight. So I don't have any distribution. I don't have any fractions. Okay, I don't even have any like terms to combine, so I'm just moving stuff. So I want to get my x by itself. So I'm going to move the 5, right? 25 equals 4x plus 5. So I'm going to minus 5 on both sides. So I get 20 equals 4x. And then we've already done the adding and subtracting, so the last is midnight. So multiply or divide. We're going to be dividing. So we divide by 4, and that gives me 5 equals x, or x equals 5. All right, let's do, the answer to number 3 is minus 6. I'm going to work number 4. 4t plus 8 is negative 12. Notice I have a plus 8. I'm trying to get this t all by itself, right? So I want to get rid of everything that's around it. But notice the thing that is right beside it, that 4, I'm going to get rid of that last. Okay, I'm going to get rid of that last. Notice the one that we just did, that 4 that was beside the x. We got rid of that last. We're going to do the same thing. So I'm going to subtract my 8 on both sides. That way I can get rid of the 8. So I have 4t on the left-hand side. Now notice, on the right-hand side, I said subtract 8, but notice it is negative 12 minus 8. That means those signs are the same. So I'm going to wind up actually adding those numbers together, and I should get negative 20. Go ahead and circle that and star it, because that's where a lot of people mess up. Anyway, I've done everything except the midnight. I've got to divide, right? Multiply or divide? I'm going to divide. So my t is negative 5. All right. So I'm going to work all 3 of these because they're fractions. Students get really confused with fractions. The good news is there is an easy way to get rid of your fractions, okay? So what you're going to do is you're going to look at the denominators, all of them. So the first one is 2x divided by 3 plus 1/3 equals 3/4. So the bottoms are a 3, 4, and a 3 and a 4. So the smallest number that 3 and 4 both go into is a 12. So that's called the least common denominator, is 12. And usually you can get the least common denominator. A lot of times you get it by just multiplying the 3 and the 4 together. Anyway, so I'm going to multiply both sides by 12. So multiply the left side by 12 and the right side by 12. Now notice when I multiply the left side by 12, first thing I'm going to be doing is distributing that 12 to both the 2x over 3 and the 1/3. So you can really think of that as multiplying 12 times everything, right? Multiply your 12 times all of every fraction. All right, so let's work this out. I'm going to look at the first one. It's 12 times 2x over 3. So I can cancel. Remember, you can only cancel the bottom, the thing that's on the first floor, the denominator, with something on top. Okay, you can only cancel when they're on different floors. So that 3 on the bottom will cancel with the 12 on the top. So 3 goes into 12 4 times. And let's see what we have left. We have 4 times 2x. So 4 times 2x is going to give me 8x. I'm going to do the same thing. I've got 1/3 times 12. The 3 on the bottom goes into that 12 on the top 4 times. So I have left plus 1 times 4. So that's going to just be plus 4. And then the last one is 3/4 times 12. So 4 now goes into 12 3 times. And I'm left with 3 times 3, right? So 3 times 3 is going to give me 9. So notice once I multiply each piece by the common denominator, I've got just a regular old equation that we've already been solving. So now it's easy. I just subtract 4 on both sides. So I get 8x is 5, and then I divide by 8, and I have a lot of students that go, you mean my answer is a fraction, 5/8? Yep, I mean you started with a fraction, so that sort of makes sense. Okay, let's look at number 6. So number 6, I've got a 2, a 3, and a 3. So what does a 2 and a 3 go into? That'd be a 6. So I'm going to multiply each piece by 6 because that is my common denominator. Least common denominator is 6. Then I'm going to go through and cancel. So I have 6 times 1/2. So that 2 on the bottom will go into the 6 on the top 3 times. So now I have 3 times 1x. So that's just going to give me 3x. And then the next part is plus 1/3 times 6. So notice the 3 on the bottom, again, will go into the 6 2 times this time. So I'm left with plus 1 times 2. So that's going to give me a plus 2. And then finally, I have 2/3 times 6. So 3 goes into 6 2 times. All I have left is what's on top, and that's 2 times 2. So that's going to give me 4. Once again, notice after you multiply by the common denominator, you should have no fractions. If after you simplify, after you cancel, you still have something on the bottom, you were using the wrong common denominator. Okay, and then from here, it's easy. I'm going to subtract my 2 on both sides. So I get 3x now equals a 2. And divide by 3. Once again, I got a fraction. That's normal. It's normal to get a fraction. All right, and then the last one. I've got a 2, a 3, and a 4. So you could, if you multiply them all together, you're going to get 24. And you could multiply everything by 24, and everything's going to cancel. All the denominators are going to cancel, and that will work. But it's not the smallest. The least common denominator is going to get you an equation with not so big numbers. But either way will work, okay? But I noticed that 2 and 3 and 4 all go into 12. So I'm going to use the least common denominator of 12. Again, you could use 24 if you wanted, but I'm going to multiply each piece by my 12. So then I come back and I cancel. So 12 divided by 1/2, 12 times 1/2 y. So 2 goes into 12 6 times. So I have 6 times 1, y. So that's just going to give me what? 6y. And then I have plus 1/3 times 12. So my 3 on the bottom goes into my 12 4 times. Let's see what I have left over. I've got a plus 1 times 4. So that'll be a plus 4. And then finally, 1/4 times 12. 4 goes into 12 3 times. So I'm going to have a 3 on the other side of the equal mark, right? Equals 3. And then once again, I just subtract. So I get 6y is negative 1/2. And then when I divide by 6, I get negative 1/6. All right, one more portion and we will be done with this section. All right, so this is the same thing. Don't freaking call me after midnight. We are solving equations. Notice number 8 and 9, I did not solve. I haven't worked it for you. I just gave you the answer because I'd like for you to try and work it. You can even pause the video right now and try and work it. But see if you can get negative 1. And on number 9, you should get 2. If you do not, then look at the notes on D2L and see where your mistake was, okay? It's really easy to make some common mistakes. So we've got 3 more to work, and then we will be done. All right, so the first one I'm going to work is number 10. I'm going to go ahead and distribute. I've got 4 times the quantity a minus 3 plus 8 equals 4 times quantity 2a minus 6. So first thing I'm going to do is don't, right? Don't, which is don't freaking call me after midnight. So I'm going to do my distributing. So I'm going to distribute that 4 times the a minus 3. So that's going to give me 4a minus 12. And then I'm just going to keep writing plus 8 equals. And now I'm going to distribute the 4 times the 2a minus 6. So that's going to give me 8a minus 24. Now, before I start moving anything, I need to get it as simplified as I can. So that is the, well, it says freaking. Freaking was fractions, which we don't have. So don't freaking call me. So now we're going to combine like terms. So the only thing I can combine really is this on the left. Minus 12 plus 8. That's what? Minus 4. So on the left-hand side, I'm going to have 4a minus 4. And that's going to be equal to 8a minus 24. And then you have options here. You can move the 8a to the left. You can move all the letters on the left or move all the move the numbers on the right. Or you could move all the letters to the right. It doesn't really matter. Let's see. I'll just move the 8a to the left. I'll get all the letters on the left. So I'm going to subtract 8a, on both sides. So that gives me a minus 4a. Minus 4 equals 24. Then I'm going to add 4 on both sides. And notice I'm adding 4 to get rid of it on the left-hand side, but I'm not really adding on the right because I have a negative 24 plus 4. The signs are different, so I'm going to subtract that, and that's a common mistake. Keep the sign of the big one. And then I'm going to divide by negative 4. So I'll get a equals 5. If you had moved your letters to the right and your numbers to the left, you would have been dividing just by a positive 4, but you would still get the same thing. Okay, so now let's do number 11 and number 12. There is a star by them. That must mean something is going to happen. I've got 3 times x minus 5 plus x plus 12 equals 6x minus 2 times x plus 2. So I've got 2 parentheses. So I'm going to go ahead and distribute my 3 with the first one. 3 times x minus 5. That's going to give me 3x minus 15. Then I can't do anything else to that side of the equation. So I'm just going to write down the plus x plus 12. Then, this is somewhat tricky. Make sure you just write down the 6x on the right-hand side and then distribute the negative 2. And again, you can think of that as plus a negative 2 if you want to, or it doesn't really matter to me as long as you're distributing a negative 2. So I'm going to get minus 2x, and then minus 2 times a positive 2 would give me minus 4. So now we do have a lot to simplify. Okay, so I'm going to go back to the left-hand side, and I have a 3x and a regular x. So I'm going to add those together, 3x plus 1x. That's going to give me 4x on the left-hand side. I'm also going to combine the regular numbers, which is minus 15 plus 12. So I'm going to subtract that, right? Minus 15 plus 12 will give me a minus 3. And then on the right-hand side, the only thing I can combine are my x's. So I get 6x minus 2x, that gives me 4x. And then I'm just going to write down my minus 4. So I get 4x minus 3 equals 4x minus 4. So I need to get all my letters on one side, so I'm going to subtract 4x on both sides. So that gives me a problem. Do you notice that all my x's disappeared? So that all I have left is minus 3 equals minus 4? Well, what does that tell me? Well, first, here's my question. Does negative 3 equal negative 4? If you owe somebody $4, can you say, no, I just owe you 3? No, they're not the same. So, since they're not the same, what that means is it doesn't matter what you put in for the x's at the very beginning. Doesn't matter what number you put in, it's never going to be equal. Because see, all the x's canceled. So when all the x's cancel and you get something that is not true, if it is not true, that means there is no solution to this problem. No solution to the problem. All right, let me do one more, the last one. I have 2 times m plus 4, then minus 3 times m minus 5, and that's equal to negative m plus 23. So first thing I've got to do is I've got to distribute that 2 to the m plus 4. So that gives me 2m plus 8. And then I'm going to distribute the negative 3 to the m minus 5. So that gives me negative 3m plus 15. Let me just sort of circle that plus because that is what a lot of people miss on tests, okay, is that sign. All right, and then on the right-hand side, there's nothing I can do. So I'm just going to write down negative m plus 23. Then let's simplify. I can only simplify the left-hand side. So let's look at my m's. I've got a 2m and minus 3m. So 2 minus 3 gives me a negative m, or you could write negative 1m if that makes you feel better. And then I'm going to take my 8. I've got 8, positive 8 plus 15. So that's going to give me a plus 23. And then on the right-hand side, I'm going to get negative m plus 23. When I add my m, to move it to the other side, notice all the m's cancel, and I wind up with 23 equals 23. So when you wind up with the same number, that means it doesn't matter what number you put in there for m, everything's going to cancel, and you're always going to get a solution. So that means, since it's true, this is true, so when it's true, that means everything works. Everything works. Okay, the problem is my lab won't let you say everything works. My lab will say, well, honestly, I say all real numbers. All real numbers. So you can write all real numbers on your test because my tests are not in my lab. So you can write all real numbers and you can write no solution. But in my lab, and I'm never going to ask you this on a test, but in my lab, they will ask you what type of equation it is. Remember, if it's all real numbers, which means it's an infinite number of answers, right? Then that is the identity. So you would write it's an identity. The contradiction is the no solution. So if they ask you what type it is, if it's all real numbers, it's called identity. If it is no solution, it is called a contradiction. And that is it. You're finished with section 6.1, so you can do your homework.